we can use a trick. And the trick we can use, if I know that the natural log of the square root of x is the natural log of x to the 1/2, how can I rewrite that?
You can bring the 1/2 forward, right?
Bring the 1/2 forward. Then, if you differentiate natural log, what do you get? You get 1/2. I mean, you just get 1 over x. You just get 1 over x.
Right?
Yeah. So, but if I just do natural log of x, it's just 1 over x.
Yeah.
So I'm not dealing with this whole thing of x to the 1/2, which is 1/2, 1 over the blob times the derivative of the blob. Now it'd be messy. You end up in the same place. So I'm going to rewrite my integral using my trick at 1/2 natural log of x dx. Saves you a world of hurt. Now what's u? Who gets differentiated?
Natural log of x.
Natural log. And who gets integrated is what's left over.
1/2 dx.
So u is the natural log of x, so that du is 1 over x dx. dv is 1/2 dx. That's what was left over. Integrate both sides, so that v is 1/2 what? X. So now, you 7 it. So the original problem, natural log of the square root of x dx equals u times v. U is the natural log of x, times v, which is 1/2 x, minus the integral of v, which is 1/2 x, times du, which is 1 over x dx. Now look how cute that is. This is the natural log, actually, well, okay, I'll just leave it this way since I did it. 1/2 x minus the integral of 1/2 times what? dx.
Oh, yeah, 'cause that's 1.
Yeah, because 1 over x times 1 over x is just 1. It's like, woohoo! Which is, I'm going to move my 1/2 x in front, which is what I wanted to do, minus 1/2. Now, what is the antiderivative of dx? X. Well, what about the next one? What's u? X. Why wouldn't I want to make it 2x plus 1 to the 99? Then I've got, well, no, if I want to differentiate, remember, u is what I differentiate. And if I wanted to differentiate 2x plus 1 to the 99, and I wanted him to go away, how many times would I have to do it before he went away?
At least 99.
At least 99 times. Do I want to do that? No. So that says this is the case of the disappearing variable.
I was there.
Okay, so this is who I want to disappear, so he's u. And I can integrate this guy, and you were right, Brendan, it is by substitution. And this is where I'll drive Travis crazy, because now I'm going to have u's in different things.
Well, there's u's and du's in both of them.
In both of them. So This is the integral of x times 2x plus 1 to the 99 dx. Sorry about that. That's, my 99 doesn't exactly look like a 99. I brought my white tape from home for a reason. I can't find my white tape here. I don't know how many I have. Okay. And so,
Where did that X come from? Oh, you're just rewriting.
we're writing the problem. So we said that u was x, so du is dx. dv is 2x plus 1 to the 99 dx, and so I need to integrate both sides. So that v is going to be something. And now what I have to do is to clear my mind completely of the u's and v's in parts, find myself a space, and say I need to integrate 2x plus 1 to the 99. I almost did that again. And this is a u substitution, a completely different u. And as one of my students said to me, she says, could I put different letters in there instead of like u and v in parts? Absolutely you can. But what you have to understand, that if you go to watch a video done by somebody else, anybody, or if you pick up a book written by anybody, parts is always u and v, always. So as long as you know that your A and B, right, is the same thing as U and V, you can change the letters all you like. That's not the big part.
You could change the letters of the U sub too, couldn't you?
You could change the letters of the U sub as well. So here we go. U is 2x plus 1, so that du is 2 dx, or 1/2 du is dx. So this becomes the integral of 1/2 u to the 99 du, which is 1/2 u to the what? 100 over 100. You're going to put a plus c in there, but we're going to move it back anyway. So what's v? Well, it's 1/2. U in this case is 2x plus 1. And in fact, 2 times 100 is 200, so might as well put that in there to the 100. But so I had to move that out of the way. And by the way, in mathematics, we have a name for this. This is called an aside, where you kind of do things to the side, do your thing, and then you bring the information back. So now we can go in and 7 this thing. So it's u times v minus the integral of v du is just dx. Now we know how to integrate 2x plus 1 to the 100 because we've already done it, right? It's going to be what? 2x plus 1 to the 101 divided by 101, but what also is going to have to be there?
1/2.
A 1/2. We'll do it again, just for the fun of it. So this is going to become equal to 1 over 200 x times 2x plus 1 to the 100 minus, now 1 over 200 times this integral. So here we go again. To the side, u is going to be equal to 2x plus 1, so that du is 2 dx, or 1/2 du equals dx. So I'm dealing with the integral of u to the 100, 1/2 du, which is what? 1/2 u to the 101 over 101, plus c, of course. So this guy comes down to b times, this is going to be 202, so 1 over 202 times 2x plus 1 to the 101 plus c.
Would it be wrong if you kept them separated, though, you know, if you just kept your half to the side?
No,
And kept that gap?
no,
Like,
absolutely not.
why did we?
Where did the 1/2?
Now remember, what I did is I took that 1/2 times 101 and made it 202.
The 1/2 comes from the 1/2 du dx.
Yeah, the 1/2 comes from here, when you make the
Because you only need the
substitution.
dx on the u sub.
The 1/2 on the u sub.
Why did you have to put it back in though, if you already did it once?
Because this is the second time around, and the second time around, you're still going to have it a 1/2.
Oh, because you have to use sub again.
You have to u sub again. So this is a u sub followed by a u sub, yeah. What I might try to do, I don't know what I could, it's very hard to video the packets in calculus. If I were on the board, I don't have to do this.